Okay, good morning, Eastern Cape learners, grade 10, 11, and 12. I'm including grade 10 and 11 deliberately because obviously every topic in mathematics starts or continues or moves from the lower grades. So grade 10 learners, you must know that you are included. Grade 11, but you know the focus is on grade 12. So we are going to start from down there when we're doing the lessons in mathematics as well as mathematical literacy. My name is M Njomeni. I am the subject planner for mathematics and mathematical literacy in the Eastern Cape Department of Education. Of course, I have the two colleagues, Mrs. Untitled as well as Mrs. Rose who will be pressing calculators and assisting me when there are calculations here. And you'll also be doing the same. So I hope at this point in time, you are aware this has been publicized through our communications and all the platforms that the department is using, that there will be these virtual classrooms. So we are starting with the lessons, and what a better way to start these lessons than with mathematics and mathematical literacy. I'm sure those are among your favorite subjects. And as you know, a pass in these subjects is very important for every learner. So it is very important to try and do your best in whatever that you do. Right, now, today we thought let us start with analytical geometry. Now, analytical geometry is a topic which obviously starts in grade 10, goes to grade 11 and to grade 12. So, what I have done here, I've just summarized it in 10 points or 10 things that you need to learn. 1, the distance between 2 points. 2, midpoint of a line segment. 3, gradient of a straight line. 4, angle of inclination. 5, equation of a circle. 6, the gradient of parallel lines. 7, gradient of perpendicular lines. 8, gradient between collinear points. 9, equation of a circle. And 10, equation of a tangent. Now, if you look at these ones, the first 8 are done in grade 10 and 11. So this is done in grade 10, grade 10, grade 10, and that one. And also in grade 11, obviously, including number 5. And then from number 6, now, the gradient of parallel lines, gradients of perpendicular lines, and gradient between collinear points is also done. Those are also done even in grade 11. And we put more emphasis on them in grade 11. Now, all those from number 1 to number 8 are your basics. And then the equation of a circle as well as the equation of a tangent are the 2 that are done in grade 12. But before you do equation of a circle and equation of a tangent, it is necessary and very important for you to know or to master these, because at the end of the day, you are still going to use all these basic things in analytical geometry when you are solving problems involving circles as well as tangents. So it is very important. By the way, a tangent is a straight line. So therefore, it means when you are working with a tangent, you are literally working with a straight line. So which means you will need to know this gradient of that straight line called the tangent in this case. And then you will need to find the equation of that tangent, which is a straight line. So it is very important, therefore, to understand that number 9 and number 10, much as they are in grade 12, the basics are needed in order for you to be able to do that. That is why now we could not just go straight to grade 12 and do number 9 and number 10. Now, today Let us do grade 10 and 11 analytical geometry, which are the basics of analytical geometry. As I indicated earlier, we are going to talk about number 1 up to number 8. Then we are going to leave out number 9 and number 10, which is the equation of a circle, as well as the equation of a tangent. We leave them out for now. Then we're going to talk about them probably tomorrow. Now, the first one, distance between 2 points. The distance between 2 points. Now, you must recall, Mfundi, that when you're talking about geometry, generally, you are talking about mainly lines, triangles, quadrilaterals, as well as circles. So we focus on 4 things: lines, triangles, quadrilaterals, as well as circles. Those 4. Now remember that triangles and quadrilaterals, they form part of, or they are the types of polygons. That is why in lower grades, in grade 8 and grade 9, you will learn a lot about polygons, which are closed figures with 3 or more sides. A polygon is a closed figure, geometrical figure with 3 or more sides. So triangles form part of polygons. Quadrilaterals form part of polygons. But the most important thing here is that our Euclidean geometry talks about these 4 things. And now remember that analytical geometry, as the name says, is geometry, it's part of geometry. But it is geometry that is done using analytical methods or algebraic methods. That is why we are going to use a lot of formulae. So we are going to be using formulae here, right? So let's get into it then. What I will do, each of those 8 things we are going to talk about, I will just write down what is it that you need to know, right? And then later, we are just going to take an example from one of the previous year's question papers, and then that will be it. So, if you talk about distance between 2 points, I will just draw a Cartesian plane, obviously, with y axis there, as well as x axis. Then if you draw any line segment and call it, line segment is a piece of line, and have a point here, says point A, and have a point there, says point B. It's a line segment. It starts from A and ends at B. Remember, Mfundi, there is a difference between a line segment and a ray. A ray continues. It will be symbolized by arrows at the ends. But now this one is a line segment. It starts from a point and ends at a point. So if you're having a line segment, it means you are having point A and point B. Now, the coordinates in analytical geometry are written in an ordered pair, starting from x and then with y. Remember, this is 2-dimensional. So there is x as well as y. So it will be x here as well as y. It will be x as well as y. Now, we must find a way of differentiating between x at A, x at B, y at A, y at B. There are mainly 2 ways of doing that, Mfundi. There are mainly 2 ways of doing that. It's either you use numbers and say this is x1 and that is y1. This is x2 and that is y2. Other people prefer to say this is xa, ya, xb, yb, because if it's at point B, that's how they separate it. But I will align myself with the way the formula sheet is given, which is given in terms of x1, x2, y1, y2. But you can use whatever you are comfortable with, xa, ya, xb, yb. Then from there, I don't want us to spend time in deriving that formula, but that formula can obviously be derived by constructing a triangle. By constructing a triangle, right? By constructing a triangle, but I don't want us to construct that triangle because it's going to take us a bit of time, and then you use Pythagoras theorem to calculate the length of AB, which is the hypotenuse. But all in all, the formula ends up, if you were to use Pythagoras theorem, being AB squared is equal to, and then you say it must be the difference between x at B and x at A. So it becomes x2 minus x1 all squared plus, and then it becomes y2 minus y1 all squared. Now note that I'm writing it literally the Pythagoras theorem way of writing it, but now we end up saying, therefore, if that is the case, what is the length of AB? And now the length of AB becomes the square root of that. Remember, if you are having squared there and you want to do away with that squared, you have AB is equal to square root of that, which is going to be x2 minus x1 all squared plus y2 minus y1 all squared. Now, this is the formula that you see in the formula sheet. So basically, that's the distance between 2 points. In this case, distance between A and B, right? The next one, midpoint of a line segment. Now, once again, I'm just going to draw it quickly. I'm drawing this so that you can also get used to drawing them. Let's say you are having point P and point Q. It's still a line segment. And then somewhere, there is the midpoint. That means the distance between P and this point, and between Q and that point, the distance is the same. So I'm going to call it point M. So it means PM is equal to QM. That is, the distance between P and M is the same as the distance between Q and M. Then we call point M the midpoint of that. Now remember, once again, any point is having coordinates in this form: x, y, x, y, right? So it's x and y and x and y. But we still have to find a way of differentiating between these 2 points. So we'll be having x1 and y1, x2 and y2. Another one may ask, which point do you choose as 1 and which one do you choose as 2? It doesn't matter, Mfundi. You can still choose at Q, x1, y1, x2, y2. It doesn't matter. The most important thing is that you must make sure that if it's x1, then it's y1. It can't be x1 and y2. It's x1, y1, x2, y2. That's why I said earlier, other people prefer to say it's xp, yp, xq, yq. But because of the formula sheet, which it just generalizes it in using numbers, I want to stick to that. So the coordinates of M, therefore, which is the midpoint, will just be the average of those. The average, okay, you just add x1 plus x2. How many things did you add? 2. So you divide by 2. And then for y, it will be y1 plus y2. How many things did you add? 2. So you divide by 2. So basically, that's how you find you find the formula, or the formula for that. I always prefer it to write it this way and say x at the midpoint. This is OR. You can write it like this one. Write x alone as well as y alone. So where you'll have x at M is the same as x1 plus x2 over 2. And then y at M is the same as y1 plus y2. y2 all over 2. So it's xm is equal to x1 plus x2 over 2. ym is equal to y1 plus y2 over 2. That's another way of writing it when you want to separate it. Then the third one is obviously the gradient. Once again, now the gradient, let me quickly draw, because I always want you to have a picture of what you are talking about. Let's say we're still having point A as well as point B, and still we're having x as well as y, x as well as y. So obviously, you will choose one of the points. I usually choose the first one as x1, y1, x2, y2. Now, generally, the gradient, remember, that is y and that is x, and we usually show by arrows there, just to indicate. So you must understand the Cartesian plane is like that one. Right. Now, what happens now there is that you are finding the gradient of a straight line. Now, the gradient of a straight line is simple change in y over change in x. Now, when you talk of change in something, you are literally talking about the difference. if you are talking about the change in y, you are saying what is the difference between y2 and y1, or the distance between y1 and y2. So in other words, you say the gradient of the line AB in this case will be change in y, which means it will be y2 minus y1 over change in x, which is x2 minus x1. So that is basically the formula that you use to calculate the gradient. These formulae are very important, learners, because these are the formulae you are going to use to solve analytical geometry problems. So it means if you can't recall what one is m, which one is m, and remember this one is small letter m compared to the one that was capital letter M. This for the midpoint is capital letter M, and then this one is small letter m. That's why you see the way I write it. I write it as a small letter because small letter m in analytical geometry is the gradient, and capital letter M is the midpoint. Right. Then from here you calculate angle of inclination. Now there is a link now coming, or integration, between analytical geometry and trigonometry. In trigonometry, you will recall that tan, if you are using a triangle, for argument's sake, and this is a right angle, let's say this is y, this is x, and that is r, and this is theta. You will recall that tan theta is the same as y over x. So which means tan theta is equal to y over x. And then when you go back, you will see that we said the gradient is change in y over change in x. Therefore, there is a link between these two things, because the gradient is change in y over change in x, and then tan is y over x, which means that the gradient m is the same as tan theta. That now is the equation for the angle of inclination. So which means if you were to have a line like that one, then you will be having an angle here, and this angle will be theta. So to get this angle, you must use the fact that the gradient is equal to tan of theta. That is done by creating, or by constructing a right-angled triangle. By constructing a right-angled triangle, and you have y, you have x, and you can have, if it was passing through the origin, you will obviously have r, but I don't want to go there because anyway we are using x and y. So tan theta will be y over x, even in this case. But the nice thing would be to make it to pass through the origin, and to not to use this one and to use that one. Then if it passes through the origin and these are y-axis and x-axis, then this would be r. So you just construct that triangle and have tan theta as y over x. And the gradient, remember, is changing y over changing x. So basically, the most important thing is for you to understand that the gradient m is the same as tan theta as an angle of inclination. Right. Now, the fifth thing that we talk about is the equation of a straight line now. Now remember that a straight line can have many points. The most important thing is for you to know that if you are having that straight line like that one, then you must know that the gradient is less than 0. In other words, it is negative. But the moment you are having another straight line, let's say like that one, then the gradient will be greater than 0. Please, take all my lines as straight lines, right? This is just a free hand, okay? So, as you can see now, that you are having a straight line. Now, a straight line must have a gradient. We have talked about that one. Now, we know that the standard form of a straight line, right? The standard form of a straight line, it is y is equal to mx plus c. Now, you can see there is m now. So m, which is the gradient. But obviously, you know that you can still use y minus y1 is equal to m into x minus x1. Now remember, if you divide both sides by x minus x1, it becomes m is equal to y minus y1 over x minus x1, which is still in the format of a gradient. So basically, you must think of these two formulae. Now C, what is C? C is the y-intercept. What is m? M is the gradient. M is the gradient. Which means if you know the y-intercept and you know the gradient, you can easily use this formula. But if you don't know that and you just know 2 points, then you can just use, find the gradient first. Then after finding the gradient, use the second formula in making sure that you calculate your equation of a straight line. They usually say leave it in the form y is equal to mx plus c. So it's very important to leave it in that format in order for you not to be penalized. Then after that now, you will notice that there's a lot of things that are said about the gradient here. If I can take you back to my first slide where I was listing all the 10 things, you will notice that there is more than 5 things that require gradient. So which means gradient in analytical geometry is very important. It's very important. Now, if we are having parallel lines, right, I will again draw with a free hand. Obviously, this is y and that is x. If you're having a line like that one, I'm going to call it line A, B, and another line like that one, I'm going to call it line C, D. And these lines are parallel. If those lines are parallel, these are the symbols that will be used to indicate that the lines are parallel. If those lines are parallel, therefore, what about their gradients? Remember, a gradient is about the slope. It's the slope, in other words. So, the gradient, as you can see that the way those lines are they are slanting the same way, which means the gradient of parallel lines are the same. The gradients of parallel lines are the same, meaning gradient of AB is the same as the gradient of CD. The gradient of AB is the same as the gradient of CD. So the most important thing is that once you are told that lines are parallel, then you must know that it tells you something about the gradients of those lines, that the gradients are the same. So if you know the gradient of this line, then you know the gradient of that line, right? Then you go to gradients of perpendicular lines. Now, what are perpendicular lines? Perpendicular lines are lines that meet or intersect at 90 degrees. If you are having this line, for instance, I'm going to call it line PQ, and another line like that one, I'm going to call it line RS. The moment this angle is 90 degrees, it means that PQ is perpendicular to RS. That is how we denote it in mathematics. PQ is perpendicular to RS. If that is the case now, when you multiply the two gradients, gradient of PQ multiplied by the gradient of RS, you are going to get a -1. When you multiply the two gradients, that is the gradients of PQ and the gradient of RS, you are going to get -1. In other words, the product of the gradients of perpendicular lines is equal to -1. Now, that is a very important information in solving analytical geometry problems. Then the last thing that I'm going to talk about under those 10 points is the gradient between collinear points. Now, the first question will be, what are collinear points? Now, it's very easy, Mfundi. Collinear points are the points that lie on the same straight line. Collinear points are the points that lie on the same straight line, which means if there is a point here, if there is a point A there, point A, then somewhere there is point B, then somewhere there is point C, right? It means that A, B, and C are collinear. A, B, and C are collinear because A, B, and C lie on the same straight line. Now, what happens now is that when you calculate the gradient between A and B, and the gradient between B and C, and the gradient between A and C, you will get the same answer. You will get the same answer. In other words, the gradients between collinear points are the same. So you get the same answer because that thing is slanting the same way, or the slope is the same, which means the gradient of AB is the same as the gradient of BC is also the same as the gradient of AC. So, take note of these three things, Mfundi. Take note of these three things. One, take note when lines are parallel, what happens? When lines are parallel, what happens? When lines are parallel, they are slanting the same way, it means they have the same gradients. What happens when the lines are perpendicular? When the lines are perpendicular, it means they intersect at 90 degrees. They intersect at 90 degrees, then the product of their gradients must give you -1, which means when you multiply their gradients, you must get -1. Then the last one, when you are having collinear points, points that lie on the same straight line, the gradients are the same. So you must note that. So that is basically the summary of your grade 10 and 11 analytical geometry, Mfundi, which is obviously needed in solving any analytical geometry problem, including grade 12. Now remember, Mfundi, I always say this. Grade 12 mathematics consists of at least 60% of grade 10 and 11. Let me repeat what I'm saying, because a lot of people don't take it into consideration. A question paper in grade 12 for mathematics consists of about 60% of grade 10 and 11, which simply means it is very important to revise grade 10 and 11 work, because those are your basics to even do grade 12 stuff in many topics except for calculus, obviously, which is a new topic in grade 12. All the topics in mathematics except for calculus are having basics in grade 10 as well as 11. So it is very important to master these things. That is why I decided that let's rather start with the basics of grade 10 and 11, so that when we continue and we do grade 12, we know that we have touched these things and we know what is it that is expected in each of the 8 things that I talked about. Remember, Mfundi, again, it's the distance between 2 points, midpoint of a line segment, that's number 2, gradient of a line, straight line, that's number 3, angle of inclination, that's number 4, equation of a line, that's number 5. And then number 6, 7, and 8 are these 3 scenarios that talk to the gradient. Number 6, when lines are parallel, gradients are the same. Number 7, when lines are perpendicular, when you multiply the gradients, you must get -1. Number 8, when points are collinear, then when you calculate the gradients between them, you should be getting the same answer. So when you are told that lines are parallel, it means you are told that gradients are the same. When you are told that lines are perpendicular to each other, it means that you are told that the gradients, the product of the 2 gradients must give you -1. And when they tell you that those points are collinear, they are saying to you the gradients that you are going to calculate between any of those 2 points will be the same. Now, what we are going to do, we are just going to go back a bit again. You know, learners, basics are very important in mathematics. That is why you'll find a lot of learners in grade 12 saying, I can't do maths, I can't do this, it's difficult, and all that. You'll find out that it's not because grade 12 curriculum or content is challenging or what. It is because of the lack of basics from lower grades. We always write or read from the examiner's reports and the diagnostic report, people who go for marking, they say learners are lacking this, that is the basics from lower grades. So I'm going to go backwards a bit again to grade 8 and 9 stuff and talk about one of the important things to solve analytical geometry, which is just knowing 2 additional things to this one, which is the properties of triangles as well as properties of quadrilaterals. Remember, when I started, I said in Euclidean geometry, we have only 4 things to talk about. 1, lines. 2, triangles. 3, quadrilaterals. 4, circles. We are going to talk about that sometime. But for now, I want us to talk about properties of triangles. Now, a lot of people will say, equilateral triangle, we all know. But now, when a question comes and say, ABC, triangle ABC is equilateral, what must come to your mind? Properties. You must now think, the moment they tell me that this is an equilateral triangle, what is it that I need to know, right? An equilateral triangle, mfundi, is a triangle where all sides are equal. This side is equal to that side is equal to that side. Equi, obviously, taken from the word equilateral. It simply means it talks to lines. So this is an equilateral triangle, PQS. It means now that PQ is equal to QS is equal to PS. All those sides are equal. If all those sides are equal, it means all those angles are equal. It means all those angles are equal. And now, what are the sum of angles of a triangle? I'm taking you back to Euclidean a bit now, for a reason. It means that now, the sum of angles of a triangle must give you 180 degrees. Now, if you take 180 degrees and divide, how many angles do you have there? You've got 3. Divide by 3, what do you get? You get 60 degrees. So, the moment you are told that a triangle is equilateral, it means they are telling you that all those angles are 60 degrees. Each of those is 60 degrees. And that's one of the things that we miss when we are given information in mathematics. We just read what is written and we don't realize what does it mean. And in this case, it simply means that each of those angles is 60 degrees. That's what we are told, basically. Let's move to the next triangle. Isosceles triangle. Now, an isosceles triangle will be a triangle with 2 sides equal. This side is equal to that side. Let's call it triangle ABC. Triangle ABC, isosceles triangle. Now, this triangle ABC is called isosceles because it has got 2 sides that are equal. Now, it means AB is equal to AC, right? Now, from there, it means once they are equal sides, you must know that they are definitely equal angles. But which angles are equal? The angles that are equal are the ones which are going to be opposite to the equal sides. So, this side is equal to that side. So, which means the angle opposite this side is that one. And the angle opposite that side is that one. So, which simply means that angle B is equal to angle C. If you want to write it using 3 letters, which is what is recommended mostly, you can write it as angle ABC is equal to angle ACB. We'll talk more about that one when we are doing Euclidean geometry. But for now, we can stick to saying angle B of that triangle is equal to angle C. And in Euclidean geometry now, we are required to provide reasons for that. And the reason for that, is not base angles of an isosceles triangle. We stopped using that in 2014 when we realized that the definition of a base was not clarified. Now it was clarified what is a base in mathematics. Then we said, let's use an acceptable reason which says angles opposite equal sides. Angles opposite equal sides are also equal. So generally in mathematics, this applies even in many shapes or triangles. Let me just stick to triangles. Once you're having 2 sides that are equal, then you must look for angles that are opposite to those sides. And you'll realize that angles that are opposite to those sides are also equal. Because generally, angles opposite equal sides are equal. The converse is also true. Sides opposite equal angles are also equal. Because sometimes you can be given this, then they say this angle is equal to that angle. Then you must know that that is still isosceles, right? Because it means that the side opposite to this angle, which is that one, is the same as that one. But I don't want us to think that always the sides that must be equal are those ones. You can still have your isosceles triangle like that one, with that equal to that. In that case, this angle is equal to that angle. You can have your isosceles triangle looking like that, and this equal to that. In that case, angles opposite equal sides, that will now be equal to that. So it doesn't have to be always the one at the bottom or which is horizontal. So you must always look for sides that are equal and then go to angles that are opposite to those sides. Now that was a bit of Euclidean geometry. When we do Euclidean geometry, you will just recall and say, what is it that we said, right? Now let's go to the last one, scaling. There is nothing much to talk about this one, to be honest. It's just a triangle. No side is equal to any other side. This is not equal to that, is not equal to that. So there's nothing you can say, especially in analytical geometry when it comes to that one. Just that in Euclidean geometry now, you must know that if you have got two angles, then you know the third angle, but we are not there. So that is scalene triangle. No side is equal to any other side. No angle is equal to any other angle, right? Now let's go to the last one, which is named using an angle now, a right-angled triangle. It's very important in analytical geometry. Right-angled triangle is a triangle with one of the angles 90 degrees, and it will be symbolized by what I'm writing right now, right? So that will symbolize that that is a right angle. It means this is 90 degrees. It means this angle is 90 degrees. They won't say it's 90 degrees, they will just indicate by showing that this is a right-angled triangle. Now, if it's A, B, C, a right-angled triangle, then it means that now, in analytical geometry, if you were given it like this, for instance, and then they say something like this one, then they say that angle is 90 degrees. What it means now is that this line, if this is PQR, what it means now is that this line PQ and this line QR are perpendicular to each other. PQ is perpendicular to QR. Now, if that is the case in Mfundi, you go back to what we said earlier about perpendicular lines, that therefore, when you multiply the gradient of PQ with the gradient of QR, you must get a negative 1. You must get a negative 1, right? Let me start over, because apparently I think something happened there. Right-angled triangle, I am saying you will have 90 degrees there. So if it's, let's say it's ABC, right? You will recognize that at B, there is 90 degrees. It won't be given to you. Now, I am saying when you have that triangle, you must realize that the gradient of AB and the gradient multiplied by the gradient of BC must give you a negative 1. That's why it is very important in the context of analytical geometry. Right, let's go to quadrilaterals now. Now, this one I will just run through it. Properties of, because I want us to do an example because our time is up. Right, now let's go to properties of quadrilaterals. We all know these things, you learn them even in foundation phase. What is a right angle? But sometimes we tend to take them for granted and not realize that the understanding of these properties is needed in solving analytical geometry problems. A rectangle, as long as you are having a situation where all these angles were 90 degrees, and then this side is equal to that, and that side is equal to that, it means that is a triangle. But now there are interesting things about those things, a rectangle. If you draw a diagonal, right? If you draw diagonals, right, let me draw it again. If you draw a diagonal is from one vertex to the opposite vertex, or one corner to the opposite corner, you will realize that the diagonals will be equal. So if you're having A, B, C, D, the diagonals will be equal. It means AC will be equal to DB or BD. The diagonals will be equal. Now, the moment you are having a point here, let's say point E, for argument's sake, point E, there is point E. Also, this side is equal to that side is equal to, and this one is equal to that one. They don't have to be equal, all the four of them. Remember, it's only this one and this one. So we further say diagonals bisect each other. Diagonals bisect. To bisect means divides into two equal parts. Bisect simply means divide into two equal parts. So when you draw a diagonal AC, when there is already a diagonal DB, diagonal AC will cut in the middle of that. So in other words, E is the midpoint of AC, is the midpoint of BD. You must take note of that because that is one of the most important things that you must understand, right? I will not necessarily state all of them, including angles, because at this point in time, we're not necessarily going to be using angles. So I will just go to a square. Now, with a square now, it's a special type of a rectangle. It's a special type of a rectangle because now it has got all sides equal. This side is equal to that side, is equal to that side, is equal to that side. It still has the properties of a rectangle, if you look at it closely. All those angles, 190 degrees, as you can see. Now, if you draw diagonals there, if you draw diagonals, right? Now, in this case, and you have point, let's say this is P, Q, R, S. If you draw diagonals, this time, the P, Q, R, S, T, let's call it T. This will be equal to that, and that, and that. So they will be equal. Take note, my diagram is obviously not drawn to scale. So for a square, that will be the situation, right? Now let's go to a parallelogram. A parallelogram, also, if you're having these two sides parallel, this side parallel to that side, and you have these two sides parallel, right? This side parallel to that one. Now we call that a parallelogram. Let's call it KLMN. KLMN. Opposite sides are parallel and equal. Another feature which is very important, this side is equal to that side, and that side is equal to that side, right? Then if you draw diagonals there, what is it that is going to happen? If you draw diagonals, that diagonal and that diagonal, you will notice that this will be equal to that, and that, let me say this will be equal to that because I've already used that sign, and this will be equal to that, right? So please take note. So still the diagonals bisect each other. As I said, I don't want to go to details, to angles and all that at this stage, right? Now let's go to a rhombus. Now a rhombus is a special type of a parallelogram because not only are these sides, two sides parallel to each other, and these ones parallel to each other. Not only that, but all these sides are equal. All these sides are equal. Which means a rhombus is a special type of a parallelogram. Opposite sides are equal and parallel. But most importantly, all sides are equal. If you draw a diagonal and another diagonal, now these two diagonals will still bisect each other. So we'll bisect this, and that will be equal, and that will be equal. They will bisect each other. But you know, furthermore, they bisect each other perpendicularly. That's another thing. Maybe I must mention this one because it's also very important in the context of analytical, because it means now this line, if this is A, B, C, D, what it means is that now A, B is perpendicular to B, D. And therefore, when you multiply the two gradients, you must get a -1. Right. Then trapezium. In a trapezium, as long as there is one pair of sides which are parallel, maybe this is parallel to that, then it doesn't matter. These ones must not necessarily be parallel. As long as you are having one pair of opposite sides parallel. And there's nothing more you can say about it because the diagonals, it will depend what type of a parallel of a trapezium is that. We've got many types of trapezium, but I don't want to go there. But I want us to just to look at the one pair of opposite sides parallel. That's a trapezium. Then the last one is a kite. The last one is a kite. Now, the most important thing in a kite is that adjacent sides this time are equal. That side is equal to that side, and this one is equal to that one. So which means if you're having it as P, Q, R, S, it means that PQ is equal to PS, and QR is equal to SR. Those are equal. Adjacent side this time. I said adjacent, next to each other, opposite, far away from each other. If you draw a diagonal here, and another diagonal there, you will realize that this will be equal to that. That means the longer diagonal usually bisects the shorter diagonal. But the most important thing is that that angle, the angle of bisection where the two diagonals bisect, is 90 degrees. Which means when you multiply, which means PR is perpendicular to QS, which means or implies that the gradient of PR multiplied by the gradient of QS must always give you a negative 1. So every time I say lines, two lines are perpendicular, then you must know that when you multiply the gradients of those two lines, you are going to get a negative 1. Basically, that is the summary of the properties of quadrilaterals. I want us to look at the formula sheet now before we do an example. Just part of the formula sheet, because sometimes we ignore this, and it's very important that you understand it. What I've done, I've just taken the top part of the formula sheet, probably the top half of it, because I just wanted to show the formulae which involve analytical geometry. As you can see, the very first formula, obviously, is a quadratic formula. You know it. It's a quadratic formula. That one, we're not there today. Then the next line, this line is for finance, right? And then these two lines, you must be able to divide your formula sheet, are for sequences and series, that is number patterns, right? And then, now remember that also in your formula sheet, there is this now, which usually links number patterns or sequences and series with finance. So this one, this line is present value and future value. You can see is connecting this and that, but mainly is part of finance. It's mainly part of finance. Then this one is for the first principles most. It's used in calculus, this one, calculus. And then, now, where we are now, we are here. Where we are here. And I can even exclude the last one deliberately for today. Exclude the last one deliberately for today. And say, today we focused on the distance between 2 points. We focused on the midpoint. We focused on the angle of inclination. We focused on equation of a line. Equation of a line. And then we focused on the gradient. So, in that 10 things that I mentioned, the first 5 are having formulae. The first 5 are having formulae. 1, distance. 2, midpoint. 3, gradient. 4, angle of inclination. And 5, equation of a line. So those 5 are having formulae in the formula sheet in front. Take note of that. Then now, number 6, 7, and 8. 6 parallel lines, gradients are the same. 7 perpendicular lines, product of the gradient is -1. 8 collinear points, gradient between those are equal. Then the last part of my lesson today is just to take one of the question papers, November 2016, Department of Basic Education, or the national paper, question paper number 2, question 3. Question 3. Question 3 of that question paper gave you, by the way, analytical geometry, you will be having 2 questions. The first question usually focuses on grade 10 and 11 work strictly. So you will either see a line, a triangle, or a quadrilateral. A line, a triangle, or a quadrilateral. And then a lot of questions will be asked based on those 8 things that we talked about: distance, midpoint, gradient, angle of inclination, equation of a line, and then lines that are parallel, gradients are the same. Perpendicular lines, product of gradient is -1. Collinear points, when the gradients are the same. So they will be based on that. And then the second question, which is usually question 4, will be focusing on circles, which is tomorrow's lesson, where we are going to be getting now into grade 12 stuff. I'm sure others are saying, we want to see what grade 12 is all about. But this is very important that you understand, Mfundi. There, every question in mathematics, especially in geometry, analytical geometry and Euclidean geometry, it will have a statement, a diagram, and then questions. Statement, diagram, questions. Now, these three things are connected to each other. You can't just look at the diagram and say, let me solve. You can't just look at the statement and say, let me solve. No. You need to read the statement together with the diagram first. That's the first thing you do. Read the statement. In the diagram, blah, 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 blah. Check with that. In the diagram, which diagram? Here is the diagram. What is happening in the diagram? A is having coordinates negative 7 and 2. Where is this A? There is this A with negative 7 and 2. B is having coordinates 6 and 3. Where is this B? Where is this B? Sorry, B is alone. Sorry for that. B is alone, it's just B. I didn't say that one. B is alone. And then there's a comma, and then there's C. C is having coordinates C. So B is there. There is B down there. Then C is having coordinates 6 and 3. Where is it? There it is. And D, where is D? There is D. Are the vertices of a rectangle. Now, they tell you that this is a rectangle. What comes to your mind, Mfundi, when they tell you that is a rectangle? Properties. What about the opposite sides? What about of a rectangle? What happens to the opposite sides? They are equal and parallel. What happens to the diagonals? Diagonals are equal. What do they do to each other? They bisect each other. Oh, okay. No, that is good. You know those properties. So it's triangle. The equation of AD is y is equal to 2x plus 60. Now remember that equation is in the form y is equal to mx plus c. So the moment they do that, they are telling you that y is equal to 2x plus 16. It means that gradient of that line is equal to, gradient is equal to 2. And the y-intercept c is equal to 16. So it means you already know something as you are reading. Line AB cuts the y-axis at G. Line AB, where is AB? AB cuts the y-axis at G. There. The x-intercept of the line BC is F is P and 0. There is F is P and 0. It tells you that there is x-intercept. Once they say it's 0 here, the y-intercept is 0. Remember in functions, the y-intercept, x is 0. X-intercept, y is 0, right? And the angle of inclination of BC with the positive x-axis is alpha. As you can see, there is alpha there. I'm not sure if you can see, but alpha is there, right? The diagonals of a rectangle intersect at M. What do you know about the diagonals of a rectangle? They bisect each other. It means M is the midpoint of AC, is the midpoint of DB. So when they ask you to calculate the coordinates of M, you are literally calculating the midpoint of AC. Those are the things that come to your mind as you read the statement, right? So that is the story. There is the equation of that line. Now take note of this, that this side is parallel to that side. And this side, once they tell you that it's a rectangle, is parallel to that side. And this side is equal to that side, and that one is equal to that one. That is the importance of knowing the properties of quadrilaterals. Then you can mark those things because you are using a diagram sheet in mathematics. We have, in an exam situation, we have an answer book. And this diagram in the question paper will be there in the answer book. Let's look at the questions now. Calculate the coordinates of M. First question, calculate the coordinates of M. I'm Fundi. I'm sure now you can see you are calculating the coordinates of M. Keep that one in mind. And then when you calculate the coordinates of M, you look at what is M. M is the midpoint of AC. And then you simply use the formula for midpoint, which is x1 plus x2 over 2, and y1 plus y2 over 2. And you can just say this is x1, y1, x2 y2. I'm just giving you a minute to complete that one. Then the other problems, I will just run through and explain to you how you approach them. So just giving you 1 minute to quickly look at that. Right. I am sure you are done with that because it is simple, taking this formula and then substituting -7 plus 6, -7 plus 6, and then 2 plus 3. Obviously, you divide by 2 in both of them. So in other words, now, when you do that, you simply say midpoint is x1 plus x2 over 2, y1 plus y2 divided by 2. And then we said at the first one is -7 plus 6 over 2. Then y1, let's just go back and see it. y1 is 2, y2 is 3. y1 is 2 and 3. So it means you add, did I say 2? 2 should be 2 plus 3 over 2. I hope, let's go back and double check that. Yes, at A, you've got 2, and then at C, you've got 3. So it's 2 plus 3 divided by 2. And then the rest is just algebra now. To calculate that, it's going to be -1 over 2 and 5 over 2. So that will be, those will be the coordinates. Then the next question, write down the gradient of BC in terms of P. Write down the gradient of BC in terms of P. Now, the question is, what is happening at BC? Where is BC? Here is BC. BC in terms of P. Now, it goes back to collinear points because at B, there is no P at B. Remember, you are writing the gradient of BC in terms of P. It means the gradient of BC is equal to the gradient of CF, which means you can use the coordinates of C and the coordinates of F, right? It's 6 and 3 and P and 0. You've got 6 and 3 as well as P, you've got small letter P as well as 0. So which means you are having those 2 points now. Let me just quickly recall what is it that was happening. That was point C and point F. So this is point F and this is point C. So it means when you are writing the gradient, remember the gradient is y2 minus y1 over x2 minus x1. So which means you can have x1, y1, x2, y2. And then you simply substitute. What is y2? 0. What is y1? -3. What is x2? P. What is x1? 6. And then you will be having your answer as -3 divided by P minus 6. That will be your gradient of BC in terms of P. Then the next question, hence calculate the value of P. Now you go back to the diagram and check where is P. P is obviously there and is in this gradient. Now which other gradient is equal to this gradient, the gradient of this line? Remember, this is parallel to that, and you know the gradient of this line, because once you know the equation, it means you know the gradient. The gradient is equal to 2. So which means the gradient is also equal to 2 of that line. Then it means that the gradient of AD is equal to the gradient of BC is equal to 2. Why? It's because AD is parallel to BC. But remember, you don't have to write this in analytical geometry. We don't expect you to give reasons for what? For your statements in analytical geometry. Then when you are in Euclidean geometry, you will have to write your reasons why that is the case. So can you see now the importance of the properties of rectangle? You can just refer and go back to those properties of a rectangle that we talked about, especially in a rectangle, and realize that all what was needed was for you to understand the properties of a rectangle, as we indicated there, that the most important thing is to know that this is equal to that, and that is equal to that. Remember, once this is 90 degrees, 90 degrees, 90 degrees, 90 degrees, it automatically means that this plus this is equal to 180 degrees, which simply means that this is parallel to that, and that is automatically parallel to that. So it means you needed now the properties of a rectangle, right? Let's quickly go back to the first where we were, right? Now, as you can see, maybe if I can just refer you back to what we were. As you can see, so far we talked about the distance between 2 points, midpoint of a line, gradient of a straight line, angle of inclination, equation of a straight line, and we talked about the fact that when lines are parallel, gradients are the same. And when lines are perpendicular, when you multiply the gradients, you get a -1, and the gradients of collinear points. Now let's go to the last one now. Let me just summarize now. I don't know. I want us to go, to where we were so that we can see. Right. So the most important thing, Mfundi, is to understand those 8 things that I talked about, plus, obviously, the properties that we just looked at. Right. I just want us to quickly go back to the questions. This is taking slower than I thought. But anyway, you can see the importance of understanding the properties. Okay, as it is still taking longer to open, Mfundi, as a summary of this and the most important things that you must remember, that substitution is very important if you are to master this topic called analytical geometry. The understanding of the shapes, Euclidean geometry, your lines, your triangles, your quadrilaterals, together with its properties, it is very important. It is very important, as you have seen, as you were solving this problem. That is where we were. So the next questions, or the last few questions now, is to find the length of DB. And if you are to find the length of DB now, it means you must know the coordinates of D as well as the coordinates of B, right? But unfortunately, at this point in time, you don't know the coordinates of D. You don't know the coordinates of B. Now they say calculate the the length of DB. You don't know the coordinates of D, you don't know the coordinates of B. Then how do you calculate that? Again, use the properties of a rectangle. And say, what about the diagonals of a rectangle? That is, the diagonals is DB as well as AC. And you will realize that those diagonals are equal, as we indicated. Therefore, it means that to calculate the length of DB, you simply have to calculate the length of AC. And then say the length of AC is equal to the length of DB. And that That is basically how you will calculate it. I think I'm just giving you directions so that you can finish it during your own spare time, right? Then the next question. So in other words, this one I can just give you a direction and say, it means calculate the length of, what was it? The length of AC. To calculate the length of DB, you must calculate the length of AC. AC is equal to DB. Those are the diagonals of a rectangle. Then to calculate the size of alpha, Mfundi, now alpha is there. You need to know the gradient. You need to know the gradient of this line. You need to know the gradient of this line, BC. Now remember again, it takes us back to the properties to say, what is the line parallel to CB? This line is parallel to that one. It simply means that if I know the gradient of this line, that the gradient is 2, it means also the gradient is 2 there. So which simply means that now tan alpha will be equal to, so this one, which is that one, it will be tan alpha is equal to 2. And therefore, alpha will be equal to, you press in your calculator, shift tan of 2. You press shift tan of 2. And what is the correct answer? Maybe it's time for me to ask what did they get, Mrs. Vakichan as well as Mrs. Lulane. What did you get there? Right? The answer will be 63,43 degrees. And remember, you always correct 2 decimal places unless stated otherwise. Right. So at this point in time, okay, the last one is just to calculate the size of OGP. There, you just use properties of triangles there. You just have to think of triangles as well as quadrilaterals. OGP. So you check, this is the angle that they say they need. This is the angle that is needed. And then you will just use properties of triangles there. You know some of the angles, especially the angle of inclination, right? At this point in time, okay, because I can see that, I'm not sure if there's something that I pressed. I wanted to go to the last slide where I was saying to you, mathematics is a practical subject. We stop here for today, and we shall do grade 12 analytical geometry tomorrow, which is a focus on circles as well as the equation of a tangent. So after that, we are going to do applications. And then remember, as I said earlier, the most important thing is to know that you need to practice. You need to practice and practice, because practice makes perfect. So you must practice, practice, and practice. And you must know that you can always master your mathematics. Thank you very much. Let's stop here for today.